The universe is vast and mostly empty, but sometimes it sends us a message, a cosmic postcard from afar. This time, the message was a comet, 3I Atlas, a traveler from another star system. It streaked into our neighborhood, a ghost from the interstellar dark, and then, unexpectedly, it changed. Right before our eyes, this ancient wanderer transformed, revealing secrets that span the galaxy. Its speed, trajectory, and chemistry all screamed, "Not from here." Each interstellar visitor is a fleeting opportunity, arriving unannounced and departing just as quickly. The stage was set for a cosmic revelation. The discovery happened on a quiet night in Hawaii. High atop the volcanic peaks, robotic telescopes of the Atlas system scanned the heavens. Their job searched for near-Earth asteroids, but on this night, they found something else. A faint fuzzy dot moved with a purpose that didn't fit. Too fast, too steep. Its path was unlike anything local. Astronomers quickly tracked it, gathering more observations from around the world. Its trajectory was a hyperbola, an open-ended curve just passing through. It had come from interstellar space. The news spread like wildfire. An interstellar visitor. For the Atlas team, this was a monumental achievement. Their system, built to protect Earth, had opened a window to the galaxy. The object was officially designated 3I Atlas, only the third of its kind ever found. The race was on to learn everything possible before it vanished. Modern sky surveys like Atlas have transformed astronomy into an active search for cosmic surprises. 3I Atlas was one of the biggest surprises yet, a gift from the deep, delivered by vigilant robotic eyes. An object's orbit is its biography. Most solar system objects travel in ellipses, bound to the sun, repeating their journeys. 3I Atlas, however, was on a hyperbolic path. A one-way ticket through our system. It was moving so fast that the sun's gravity could only bend its path, not capture it. It had fallen from interstellar space, and after a brief encounter, would be flung back out, never to return. The rarity of such an event is staggering. For a small object to travel for eons and pass through our tiny solar system is an astronomical long shot, yet we've now seen three, Oumuamua, Borisov, and Atlas, suggesting these wanderers may be more common than we thought. Observing them is a frantic, one-shot opportunity. Every measurement is precious. We must mobilize our best instruments to capture a snapshot of this fleeting messenger. The hyperbolic journey of 3I Atlas was a ticking clock, challenging us to uncover its secrets before it was gone. And as luck would have it, we had an observer in a very special location. Far from Hawaii, another robotic explorer was at work. China's Tianwen-1 orbiter, circling Mars. Its mission studied the red planet, equipped with high-resolution cameras. But science is about seizing unexpected opportunities. Astronomers tracking 3I Atlas realized its path would bring it into view from Mars' orbit. For a brief period, the comet would be perfectly positioned for Tianwen-1 to observe. The decision was made, temporarily divert Tianwen-1 from its Martian duties. Reprogramming a deep space probe is complex and risky. The spacecraft had to be reoriented, its cameras recalibrated to search for a faint moving target in deep space. This was a high-stakes gamble, using a precious asset for a task it was never designed to do. But modern missions are becoming more flexible, ready to respond to new discoveries. Tianwen-1, the Mars orbiter, was about to become an interstellar comet observatory. It was a testament to ingenuity and the collaborative spirit of science. A Chinese spacecraft orbiting Mars would provide the world's best ever view of a visitor from another star system. The universe had presented a target of opportunity, and humanity was ready to take the shot. Sometimes the cosmos rewards those who are prepared for the unexpected. The technical challenge was immense. Imagine photographing a speeding firefly in the dark, from a moving car, with a camera built for landscapes. The Tianwen-1 team had to calculate the precise movements of both orbiter and comet, aiming at an empty patch of space, trusting the comet would arrive at the right moment. Engineers sent new commands across millions of kilometers, carefully pivoting the spacecraft. The camera, designed for Mars, was adjusted for long exposure imaging of a faint object against the void. From Earth, the comet was hard to see, too close to the sun, but from Mars, the viewing angle was perfect. The sun was out of the frame and the comet was closer to Mars than to Earth. This parallax effect gave Tianwen-1 a front-row seat no Earth observatory could match. As the commands were uploaded and the spacecraft turned, tension filled mission control. They had done all they could. Now it was up to physics and their robotic emissary. The camera would take a series of images, staring into the darkness. Would the gamble pay off? In the cold silence of space, Tianwen-1 waited for its target. The data streamed back to Earth. Ones and zeros, reconstructed into images. There it was, a faint fuzzy smudge against distant stars. Success, but as the team processed the images, they saw something astonishing. The comet was changing. In the initial images, 3I Atlas appeared as a dull, reddish point, its surface baked by eons of cosmic radiation. But as it neared the sun, something inside began to stir. The ancient ice beneath the crust started to vaporize. Suddenly, the comet flared to life, brightening and shifting to a vibrant bluish green. This is the classic color of an active comet, frozen gases sublimating, forming a glowing atmosphere. When these molecules are struck by ultraviolet light, they fluoresce, emitting greenish-blue light. Tianwen-1 was watching a primordial object from another star system wake up in real time. This was unprecedented, witnessing the chemistry of another solar system unfold before our eyes. The activation showed the reddish crust was only skin deep. Beneath lay a pristine core of volatile ices. The process was rapid. A sudden outgassing event blew off the dark surface, revealing fresh, icy material. Tianwen-1 hadn't just taken a picture, it captured a live chemical reaction on a cosmic scale. For the first time, we saw the raw ingredients of a world born around another star. This was a direct look at the chemistry that builds planets. A cosmic transformation, caught in the act. The observation of 3I Atlas provided a crucial new piece to an unfolding puzzle. We now have a small but growing family of interstellar visitors, each telling a different story. The first, Oumuamua, was a reddish inert enigma, no coma, no tail, behaving more like an asteroid. Then came Borisov, which looked and acted like a typical comet, with a familiar chemical makeup. Borisov's message comets in other star systems might be made of the same basic stuff as ours. 3I Atlas bridges the gap. It arrived looking inert, then transformed into an active comet. This suggests Oumuamua may have been a dormant comet, its ices sealed beneath a crust. 3I Atlas showed this process in action. The reddish inert state is temporary. Given enough warmth, the true cometary nature bursts forth. This single observation recontextualized our understanding of interstellar objects. It provides a potential life cycle, born icy and active, baked into dormancy, reawakened by a star. The story of our 3 interstellar visitors is becoming richer and more coherent with each new discovery. Each one adds a new chapter to the cosmic narrative. Why does a comet changing color matter? Because that color change is chemistry in action, a direct window into the ingredients that build worlds. The shift from red to bluish-green on 3I Atlas revealed a surface of complex organics and an interior rich in volatile ices. These are the same building blocks believed crucial for the origin of life on Earth. The presence of cyanogen, a precursor to amino acids and DNA components, is profound. Finding them in a comet from another star system suggests prebiotic molecules are common across the galaxy. Comets could be seeding young planets everywhere with these vital ingredients. The data from Tianwen-1 provides a rich chemical spectrum for scientists to analyze for years. By comparing 3I Atlas to our own comets, we can start to understand the diversity of planetary systems. The recipe for life might be written into the very fabric of the cosmos. The encounter was brief. 3I Atlas is now speeding away, its journey through our solar system a fleeting moment in its billion-year existence. We will never see it again, but the data it left behind will keep astronomers busy for decades. The images and spectra from Tianwen-1 are a precious gift, a single frame from the galaxy's grand movie. Future telescopes, like the Vera Rubin Observatory, will be on high alert for the next interstellar visitor. We expect to find more, each adding another piece to the puzzle. The era of interstellar archaeology has begun. This discovery was a powerful example of global scientific collaboration. An American survey found it, a Chinese probe observed it, and scientists worldwide are analyzing the data. In a world divided by borders, the search for cosmic knowledge unites us. The story of 3I Atlas is a story of wonder, reminding us the universe is dynamic and full of surprises. There are mysteries unfolding, all around us, from Mars to the dark spaces between the stars. We have only to keep our eyes open and be ready for the unexpected. The journey of 3I Atlas continues into the darkness, but it has left a trail of light in our understanding. The universe is speaking, and we are finally learning its language.